Welcome in a lesson about task completion source. We will cover here what a task completion source is, when you can use it, in what scenarios you can use it, or maybe in what scenarios it is not so necessary as it looks like in the very first glance. So in general, task completion source is a factory of tasks that will be completed at some point in time, in some point in future. So, as I said, at some point in time, you can use a try set result or try set exception methods on task completion source instance, and it will set the result, the state of the task that is returned by a task property which is provided in task completion source type. So on one hand, you have a task completion source and it has task property, so it can be returned to the caller, so it will be awaited, you can call .result on it, you can do whatever you want with the task itself, and this task represents an operation that is controlled by task completion source. On the other hand, probably from a different thread, you will be interested in changing the state of this exposed task with the help of those methods. Very typically, we use task completion source FT, and it is a very helpful method in building a task wrappers around legacy code, which provides kind of asynchronous operation, but it is not task compatible. So we will just wrap this old operation into something that is a task compatible version. So a typical example is to wrap event asynchronous pattern, as was described in one of the previous lessons. So we have, for example, kind of method which is called download string. It is a legacy code because it does not support any task compatibility. It starts an operation of downloading a string from a given URL, but then you can be notified and you can consume the result by the provided callback, a callback provided to this method. So it would be not possible to use task directly here. But we can use task completion source, and because download string is a method that is just returning a string, we are using here task completion source of string because we are interested in wrapping all this stuff into a task string. So what we do here, we are newing up task completion source of string, then we are starting this asynchronous operation with the help of download string method, and from now this operation has started in background and the whole HTTP request processing has been started, and in the end we also make this callback registration that will use task completion source to change the status of this operation. And then this obviously ends because this is just kicking off asynchronous operation, so download string by itself takes a small amount of time, and we return from this method a task that is provided by this used here task completion source. So from now, someone who is calling download string async has task and it can await it, for example, or it can use .result on it. And inside this callback that will be called at some point in time in future when this operation ends, and then we are using those methods try set exception and try set result just to set the status of this exposed task. At this point, when we call try set result, for example, the awaiting thread will be waken up because it is just a moment when this task has completed and we can make continuation because the whole state machine now can process this asynchronous operation. So you can use this approach to wrap any event asynchronous pattern or in general any async API that is not directly supporting tasks. If only there is kind of callback that can be registered when the operation, the asynchronous operation ends, you can use task completion source and set the state of this operation just with the help of those try set result method or try set exception and so on. Thanks to that, we can write quite complex code, which is also an example of using task completion source. We will cover this in arrival order approach in the lessons about when any and when all. In general, our goal here is to process tasks as they are ending, not to await them in an order provided in code. So we have a bunch of tasks and we want to await on them, but we want to await in a manner that will just end the first finishing task, and it will be awaited as soon as it ends in the arrival order. We are using TaskCompletionSource to have this possibility to make the exposed task wrapped inside a different task, and then those tasks can be awaited. This is quite complex code, which is using also something which is called interlocked increment. It will be covered in a lesson about low-level APIs related to threading, but in general, I hope you see here an overall goal and approach in this code. So here we are just calling toList at the very beginning of this method because we are getting an enumerable of tasks. We want to make sure it is a materialized collection, so every task now will start. And then we are mapping every task to a new task completion source. Then within a loop, we are just configuring things. So for every task that has come as an input for this method, we are using and adding a continuation with a well-known continue with method. And this continue with method is adding continuation that will be responsible for filling the next subsequent result in some collection. In our case, this collection is just the collection of task completion source. So we will be calling try_set_result for a successive elements of our task completion source collection, which means they will be just completed in an arrival order. And in the end, we need to expose all those things, so we are just using select to return a collection of tasks will be just a collection of the task exposed from the corresponding task completion sources. That's quite complex code, but it really nice wraps various APIs related to async, await, multi-threading, tasks, so I really like this example. Please do not hesitate to make a break and wait until you understand this code so you can watch it, you can try to copy paste it, you can try to use it and just to understand how it works and why. Here we have also very important, although quite small and detailed side note. You should remember that by default, task continuations are inlined on the same thread that is calling try_set, exception, result, or cancelled. This may be not important in many scenarios, but I will show also scenarios in which it is very important. So as we have here doSomethingAsync method, this method is using TaskCompletionSource to wrap our legacy async operation. And again, similarly to the previous examples, we are using here an event handler, which in this case is an event handler of a completed event. And this event handler is setting a result of our task completion source. So the exposed task will just be completed because of that. So imagine that someone awaits this task which is returned from doSomethingAsync method. So one thread is awaiting this at some place in code, and the other place we are calling set result inside an event handler on some thread because we just doing some callback, so this callback is scheduled from somewhere on some thread. And because it is inlined, it means that the continuation of this await continuation from the different thread in fact will be inlined here. So we will be just continuing executing this continuation of the async await method that awaits this task here inside the code just after the set result, exactly on the same thread that was being executing a callback scene here. As we will soon see, in some scenarios it can be dangerous, and that's why it is a good practice to always add this additional configuration. Every time you new up a task completion source, just for a clean good practice, you can add this run continuations asynchronously additional option. So now, when this callback is being executed, the continuation of the something that awaited on our task, this continuation will be executed on a different thread than the one that called set result in our case. So maybe this all is not so clear for you why they can be a problem, so here is a very nice example which is exposing this subtle error. This code is inspired by the Kevin Goose article, blog post called Performance Best Practices in C#. So here we have a very nice deadlock, because as we see, we are using a console application, and inside the main method we are calling deadlock method, which is starting an asynchronous operation, because as we see, deadlock has an async task signature. But because it is exposing a task, we are just doing sync over async by calling wait on the returned task. So let's see what the deadlock is doing. Deadlock has two steps, and the first step, it is just starting an operation represented by process async method, and it is awaiting a returned task. Nothing very interesting. Then we have a mutex being used. A mutex is here a manual reset event slim, which is kind of flag that can be raised and awaited. So here, for example, we are waiting on this flag. By default, this flag is not set, so the mutex.wait means here we will wait until this mutex will be set from a different place. So deadlock is quite easy. Let's look at the process async. Process async is the one that started our asynchronous operation, but it is not async because we are not awaiting here anything, but it is not an important thing for this example. What is important is that we are using TaskCompletionSource here, and we are using task run to create this asynchronous operation, to delegate this operation to a worker thread from a thread pool. So here we have a very simple code. In fact, it is just waiting, sleeping this particular thread for 1 second. And after that, we are calling TCS set result, which means we are setting a result of the represented task to be completed. Because we are newing up task completion source here, and from the process async we are exposing the corresponding task with the help of the task property as in the previous examples. But the problem here arises because set result, as we said, are inlining the code of continuations of the exposed task. So here we have this problem that when we call .setResult, in fact, just after setting the result, indeed we are inlining continuation of the awaited task. In this case, we are awaiting in the deadlock. So we are just inlining in the continuation of this await, which is mutex.wait. So we can imagine this conceptually, that just after the set result call, we are inlining the execution of mutex.wait method. And because of that, we are in a deadlock scenario now, because we have started waiting on the mutex, but the rising and setting this mutex is just in the next line, which will never happen because we have just started waiting on the same mutex from the same thread. So here is this subtle error that can be introduced when you mixed sync over async and task completion source, which is just using this default behavior of inlining continuations. This is very similar to this case of synchronization context. In general, everything is fine as long as you don't use sync over async. But because you don't know if someone will use sync over async, by default a good practice on the reusable library code is to call configureAwait with false just to get rid of the problem of deadlock. And exactly the same approach here. Here we are just by default using run continuations asynchronously just to get rid of this risk of being deadlocked, because we don't know how this operation will be used, or maybe someone in the upper layer will use sync over async. So for clarity and to be on the safe side, by default every task completion source could be used with this flag run continuations asynchronously, which in this case solves our problem, because .setResult will happen on the same thread, but this setting, the continuation of the deadlock method, will be executed on a different thread. Then we will set the mutex, and then we will wait on the mutex. And there will be no deadlock. In the end, the main method will just end successfully. By the way, if you don't like the fact that in the previous slides we've used a task completion source of bool because we needed some type there provided, because in general task completion source has only a generic type version, then in .NET 5 the non-generic version of task completion source will be eventually added. So instead of creating sometimes an artificial task completion source of bool or any type and then setting results like false or null, then we will be just having this task completion source for some scenarios when we are really exposing task and not task of T. Regarding task completion source, quite often you can meet it with the correspondence with the unit testing. Because when we do a unit testing, probably we need to mock some dependencies. So here you have a very simple unit test that is just using Moku to mock some dependency, which in this case is a repository, and this repository has a getCustomer method. So we are just mocking it and saying that when it will be asked for a customer with a given ID, we will just return a given customer data. And then we consume this mock inside a domain service for test whether the activation of the customer has succeeded or not. But here we are using task completion source for doing that because we need to provide a kind of guarantee that when this asynchronous getCustomer method will return, it will return a task representing this result. So here we are just using it, newing up a task completion source of customer, and then our method getCustomer just returns a task exposed from this task completion source. And just after that, in the next line, we are immediately setting this to the result with the given customer. So now when someone will call this method, the task in a completed state will be returned and it will contain the customer data. You probably agree this is quite a complex code for such a simple scenario. And this is mostly because of pre.NET 4.5 times when async await was introduced and task.fromResult was introduced. So now, since .NET 4.5, we can use just task from result, so we don't need task completion source for this particular scenario. If you see task completion source because of that in your unit test, you can probably safely migrate to using task.fromResult. It is much safer and cleaner to understand for the reader. Or even use some async support from the mocking libraries, like Moku supports returns async method, which is just accepting the result of this asynchronous operation. We even don't need to use this task.fromResult method. And this in general concludes our lesson about task completion source. There is not too much to say about it. We will sometimes return to it also in the further lessons, but for now it is just completely fine for you to know all the stuff described so far. And again, if you like reading, we invite you to read those articles. Let's just also conclude with some simple demo that will illustrate you wrapping around the event asynchronous pattern with the help of the task completion source. In this demo, we are using again Windows Forms because it is so convenient and simple to use it for demos. So here our goal is to wrap a background worker into something that is Task API-like. So our goal is to start an operation with the help of background worker, which will be working obviously in background in an asynchronous manner, but have possibility to await on the task instead of using the background worker directly. So the main point here is to wrap this background worker, and it is done with the help of this extension method on the background worker, which is called runAsync. So we have our own extension method, and as you see, we are using here task completion source very similarly like in the previous examples. So the main point here is that we have our worker, and there is also an action being provided to this runAsync method, which is just the action that should be done in background by the background worker itself. So the structure of it is very similar to the previous ones. So we have here a task completion source being new up, and as a good practice, we are using run continuations asynchronously just because it is a good default decision. Then we are configuring this background worker. So for example, we are interested in worker reports progress. So we are setting it to true. We also want to support cancellation. So we are also setting this property to true. Then we configure those two most important events. Do work is the event that is just providing the work to be done, as it was described in the lesson about the background worker. So here we are just directly calling our action that has been passed as an argument. This is the work that should be done. It was that provided as an argument here, so we would like to do that. And then we need this place that will just observe that this operation has ended. And here it is a run worker completed event. So we are again registering here an event handler about that. So it is just an event handler that inside is observing whether this particular work has succeeded or not based on the error property. And we are using the task completion source to set the result or exception depending on the result. And then obviously we are starting this work to be done with the help of run worker async method of the worker. And we are obviously all those methods are very fast because it is only a configuration of the worker and starting asynchronously this operation. So the whole method is very fast. And then we are exposing the task from inside the task completion source. So from now someone can await or observe the result because we have a task to observe. So run async has very similar structure as the previously described. Let's see how it is used. So here we have a button save click handler, which will be shown soon when I run this application. And this is the main work when our run async method is used. So here we are newing up our worker. We are just using it in a quite classical way. So for example, we are using progress changed, event being raised when there will be progress reported. And also just to visualize the work, just before the work I'm changing the background color, and just after this work is done I'm reverting it to the previous value. And here we have the usage of our run async method. The most important part is that while now it is just returning task, we can await it. So now we have a convenient async await based API which you can use inside an async methods, and now we are just awaiting the result of this run async. And inside we are just populating it with the action provided that is responsible for doing some work. In this case, because we just want to simulate this work, it is just a sleep which is repeated 10 times. So it is just to simulate some ongoing work. During this loop, we are reporting progress. So we will be able to see the progress being changed, and also we are supporting cancellation. So this lambda is here because we want to have access to worker, and that's because of that this worker is captured. So because of that we need lambda here as the simplest solution for this problem. And this is now working asynchronously, so we can run this demo and see how it behaves. And obviously the UI is very sophisticated for this demo. We have one button, save, which is handled by this described event handler. And when we click it, we see that indeed the UI is responsive, the progress is being reported, and everything is working as expected. So we have here a pretty good example of wrapping background worker to an async task API based API. And obviously we can also cancel the operation. It supports cancellation because we have this code about cancellation inside our action run from a worker. So this is kind of wrapping our background worker from event asynchronous pattern times inside and into something which is based on tasks, so we can await things now instead of using background worker directly. You could think about making it even more sophisticated, for example, to hide background worker completely or something like that, but for now it is just a good example of usage task completion source to wrap things around to do more task-based APIs.